Hello guys, trust you're doing fantastic. In today's video we're going to be talking about the excess 3-code subtraction of 10's complement. So we're going to be looking at case 2. In our previous video we looked at case 1. So case 2 is going to be subtracting larger from smaller number. Now let's go over the rules. Rule number 1 says we need to take the 9's and 10's complement and excess 3 code for the subtract end. Rule number 2, add it to the minuend, excess 3 code. 3, if carry is generated, shift the carry to the next bit with errors. Rule number 4, add 3 to the carry generated bit and subtract 3 from the bit without carry generated. Now the 5th rule says if n carry is not generated, take the 9's and 10's complement again. Alright, so we're going to look at how we can apply these rules in solving a problem of excess 3 code subtraction of 10's complement, where we're going to be subtracting larger number from a smaller number. So let's take a look at this example. It says, what is the 10's complement excess 3 code subtraction of 235.25 from 111.62? Alright, so by solution, what that means is 111.62 minus 235.25. So the value you have on the left hand side is called the minuend, and the value you have on the right hand side is called subtrahend, because we're actually subtracting this value from this other value. Alright, so these are the things you need to take note. Now if you have to follow the rules, it says that we need to take the 9's complement of the subtrahend. Alright, so taking 9's complement of the subtrahend means that we need to subtract each and every digit in the number from 9. Alright, so we have 9 minus 2, we're going to get 7, 9 minus 3, 6, 9 minus 5, 4, we get 9 minus 2, 7, 9 minus 5, we got 4. So that is how we arrive at this value. Alright, so the next thing we need to do is to take the 10's complement of this value that we have derived after taking the 9's complement. Alright, so taking the 10's complement of the result obtained, it means we need to add 1 to this value. Alright, so we say 4 plus 1 is 5. We bring down the 7. We have the period. We bring down the 4. We bring down the 6. And we bring down the 7. At this point, rule number 2 says after obtaining this result from the 10's complement, all we need to do is to add this result to the minuend. Alright, so this is what we're going to do. So before we add this result to the minuend, we need to take the excess 3 code of this result. So taking the excess 3 code of this result, meaning we need to add 3 to each and every digit in this number. So we have the excess 3 code of this result is going to be 764.75 plus 333.33. So we're going to be adding 3 to every digit in this number. So 5 plus 3, 8, 7 plus 3, 10, 4 plus 3, 7, 6 plus 3, 9, 7 plus 3, we have 10. So this result is what we have obtained after taking the excess 3 code of the 10's complement result. Now after obtaining the excess 3 code, we need to take the BCD, the binary coded decimal of this result, the excess 3 code result. So what we do is that we're going to assign 4 digits. We're going to assign 4 bits to each and every digit in this number. So we have 10. This is the binary code of 4 bits that represent 10. So 9, this is the binary code of 4 bits that represents 9. 7, this is the binary code of 4 bits that represents 7. 10, this is the binary code of 4 bits that represent 10. And then 8, this is the binary code of 4 bits that represents 8. So in this case, we've been able to express this value in BCD. So the next thing we need to do is to take the XS3 code of the minuend. Now, taking XS3 code of minuend means adding 3 to each and every digit in this number. So let's do that. We have 111.62 plus 333.33. Now let's carry out the summation. We're going to have 2 plus 3 is 5. 6 plus 3 is 9. We have the period. 1 plus 3 is 4. 1 plus 3 is 4. 1 plus 3 is 4. So we've obtained the XS3 code of the minuend. And then all we need to do next is to convert this into BCD. Now, to convert this into BCD means we need to represent each and every digit by the corresponding 4 bits in binary. So the equivalent in binary in 4 bits of 4 is going to be 0100. So this is the binary equivalent represented using 4 bits. And then we'll do that for the next 4 and then this other 4 period. And then the binary code of 4 bits for 9 is this 1001, and then the binary code of 4 bits for 5 is 0101. So in this case, we've been able to express this value in BCD, from which we're going to carry out the further operation. Remember, the next step is to add the result to the minuend. So what we have gotten from the subtrahend in BCD, we need to add it to what we've gotten also for the minuend in BCD. Alright, so next we're going to add what we have to the minuend. So this result is the BCD for the subtrahend, and then this is the BCD for the minuend. So let's carry out this addition. 0 plus 1, we're going to have 1. 1 plus 0, 0. 0 plus 1, 1. 1 plus 0, 1. 0 plus 1, 1. 1 plus 0, 1. 0 plus 0, 0. We have 1 plus 1 is going to be 0 with a carry of 1 written in this red ink. We're going to bring down this carry. Now we have the period. 1 plus 0 is 1. 1 plus 0 is 1. 1 plus 1 is 0 with a carry of 1. The 1 is indicated in red ink. So we say 0 plus 1 plus 0 is going to be 1. Now move over to the next segment of bits. 1 plus 0 is 1. 0 plus 0 is 0. 0 plus 1 is 1. 1 plus 0 is 1. Now move over to the next segment of the bit. We have 0 plus 0, 0. 1 plus 0, 1. 0 plus 1, 1. 1 plus 0, 1. Now we have gotten our answer. Now if you notice, in this segment of the bits, this segment, we have carry generated. Carry is generated at this point. So what we're going to do in this case, since carry is generated at this point, the rule says that if carry is generated, we need to shift the carry to the next bit. Okay, we need to shift it to the next bit. So in this case, we're going to shift this carry to this part. Then we need to perform another summation operation. So we're going to have this. So this is shifted to this part of the segment of the bit, and then we're going to sum up everything all over again. So for this part, we're going to bring down everything. 1, we'll bring down 1, bring down 0, bring down 1, bring down this 1. This other one will bring it down. This one will bring it down. 0, bring it down. 0, bring it down. Right. So this carry has been shifted to this part. So we have our period, and then we say 1 plus 1 is going to be 0 with a carry of 1. So this first red ink is the first carry. So say 1 plus 1 is 0 with a carry of 1. 0 plus 1 is going to be 1. Then we have this 1 down. And then every other thing we have here, we have to bring them down here. Right, so in this case, all we need to do, since we have observed that carry was generated in one part of the segment of the bit, now that says that we need to add 3 to the carry generated bit and then subtract 3 from the bit without carry generation. So in that case, 3 in binary represented in 4 bits is going to be 0011, 0011, 0011, 0011, 0011. Now the rule says we need to add 3 to the carry generated bit. So it was this bit, the second segment of the bit that generated carry. So we're going to add carry. Then with the other segment of the bit that did not generate carry, we have to subtract 3. So that's why you have minus, 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 and this part you have plus, and this part you have minus. It's according to rule number 4 that says add 3 to the carry generated bits, okay, and then subtract 3 from the bit without carry. So this is what we're doing. Now if we carry out this operation, we're going to have this 1 minus 1, we're going to have 0, 0 minus 1, 1, 1 minus 0, we're going to have 0, 1, we're going to have. Alright, so let's go through the easiest way to carry out this operation, which is very easy. Now if you look at this binary, this is 13, this is 8401, so this is 13. So you say 13 minus 3, 0011 is 3, you're going to get 10, 1010. Now you have this, which is 3, 3 plus 3, this, if you sum this up, you're going to get 6. You're going to have 0110, which is 6 dot. This in binary, this is 12. So 12 minus 3, you're going to get 9, 1001. Move over to the next segment. This is 13. So 13 minus 3, you're going to get 10, 1010. Then move over to this last segment of the bit. This is 14. 14 minus 3, this will give us 11, which is 1011. So this is the shortcut and the simplest way for you to carry out this operation. So according to rule number 5, it says if n carry is not generated, then we have to take the 9th and 10th complement again. So we can see that from this part, n carry is not generated. So in this case, since n carry is not generated, then we have to take the 9th and 10th complement again. So the 9th complement of this, so the 9th complement of this result will be taking the inverse of this result. So wherever we have 1, we're going to have 0. Where we have 0, we're going to have 1. Where we have 1, 0, 1, 0. So we'll have 1, 0, 1, 0. So it's going to be 0, 1, 0, 1. So we're going to take the inverted form of this. So we're going to take them. So the inverted form of this, which is 1, 0, 0, is going to be 0, 1, 1, 0 dot. So this is going to be 0, 1, 1, 0. So the inverted form of it will be 1, 1, 1, 0, 0, 1. And then for that of 1, 0, 1, 0, it's going to be 0, 1, 0, 1. So 9th complement is simply taking the inverted form of the result. Then the next step is for we to take the 10th complement, and the 10th complement would be to add 1 to this result we have taken in 9th complement. So let's carry out this operation. So we're going to have 1 plus 1, it's going to be 0 with a carry of 1. 0 plus 1 will give us 1. Then we'll bring down this 1, bring down this 0. And then every other thing we have on this side, we're going to bring everything down. We're going to have the same result. So in this case, at this point, we need to get the equivalent of this binary representation in decimal. So this is going to give us 6. This is going to give us 9. This is going to give us 6. This is going to give us 5. And this is going to give us 4. Now we'll have to look for the excess 3 code of this value. So the excess 3 code of this value is going to be 4 minus 3 will give us 1. 5 minus 3 will give us 2. 6 minus 3 is going to give us 3. 9 minus 3 is going to give us 6. And then 6 minus 3 is going to give us 3. So it means the SS3 code of this value is 123.63. So I have written that below. So therefore 456.96 is the SS3 code of 123.63. So if you've gotten to this point, it means you have gained sufficient knowledge in calculating SS3 code subtraction of 10's complement, where we consider subtracting larger number from a smaller number. So I'm going to encourage you to pay attention to the subsequent videos in this channel.